Hey, Computational Thinking, Tennyson here, and we're going to be working through the last step in our Caesar Cipher project, which is creating a brute force attack on our Caesar Cipher encryption. Um, so essentially what we're looking to do here is break or crack the encryption or an encrypted message, I should say, that we create. And it's important to make a distinction between decryption and cracking encryption. Decryption means we knew the key, we are the intended recipient of the message or data, and we didn't have to do anything special outside of the normal process to look at the plain text. That's decryption. Cracking encryption means we are using some method to essentially break the encryption without knowing the key in advance. So if you think about it, typically that's like a unintended or someone that we didn't intend to receive our message is trying to look at it. So a couple of things that we need to do in order to set this up. The very first thing I want you to notice is I've reduced alpha to ASCII letters, space, and a period. This just keeps things simpler for you. You can continue to attempt doing it with digits and punctuation plus a space, but I would encourage you to just reduce alpha to this for the purposes of this part of the project. The next thing we need to do is we need to sort of hide the key that we are encrypting our message with. So before we were doing a key of 3, this time we want to hide our key and we don't want to let ourselves know what the key was. That way when we go to decrypt it, when we go to break it, we kind of have to test out every possible key, and we'll talk about how we do that. So what we need to do here is we need to import random, and while I'm up here, I'm going to use the time library later. I'm going to go ahead and import that too. Okay. So here for key, I'm going to say random.randint, and we're going to have a key between 1 and the length of alpha. So the length of alpha dictates basically the maximum key that you could possibly encrypt with. Okay, the next thing that I'm going to do is I'm going to go down here to my main function, and I'm going to write this cracking algorithm. So the way that that's going to work is I'm going to first obviously create my encrypted message, and that's still going to be in user output just as it was before. Now your code might look a tad bit different, but remember we set up this Caesar Cipher function so that it accepts a mode, and we're getting the mode from the user at some point, and we're passing that in as an argument so that Caesar Cipher knows whether or not it's going to encrypt or decrypt. So we want to start out by encrypting our message. We're going to get an encrypted message in user output, and then we're going to try to crack it. So that's going to look like this. We'll go ahead and just set a little breakpoint here, for lack of a better term, and we'll say, hey, do you want to crack this encryption? Yes or no, and we're obviously going to say yes, and then we'll say if crack encryption is equal to y, then we're going to do the following things. One, to understand what we need to do in order to break the encryption of Caesar Cipher, basically what we're going to do is we're going to brute force attack the encryption, which means we're going to try every possible key, and we could theoretically, and not theoretically, we could absolutely write an algorithm which determines whether or not a given brute force attempt matches the English language. Like we could say, does this look like plain English when it returns? And then we could write an algorithm around that. That would take a while. We'd have to talk about some natural language processing stuff, probably. I really don't know, but that's not really what we're going for here. We're just going to use our eyeballs to determine if we crack the encryption or not. And I feel like that's the most basic and interesting way to look at it without getting too complicated for a short video. Okay, so here's what we're going to do. If we want to attempt to crack it, we need to set our attempts to 0. And this is basically going to be our way of running through all the possible keys. And we're going to say while attempts is less than the length of alpha. Remember, the length of alpha basically dictates what the maximum number of keys I can have is. We're going to print a new line in there just to have some space. And then we are going to make our brute force attempt. So we'll store this in a variable, and all we're going to do is we're going to run Caesar Cipher. We're going to run it with our user output. Remember, this is the encrypted message, so we're going to pass that in as the message. We don't know the key, so we're attempting all the possible keys. Therefore, our key argument is going to be attempts, and then our last argument, mode, is obviously going to be decrypt because we're trying to decrypt with a bunch of different keys. All right, once we've gotten that brute force attempt, we're going to print it out. And I also want to know what attempt it is, so I'm going to say, hey, this is the key we tried, and that's correlated to attempts. And then we'll have a new line, and we will include the brute force attempt. All right. Once we've done that, we've made one attempt. That means we need to increment attempts by 1, so we'll say attempts plus equal 1. All right, let's run this code and see what happens. So I will type in something like the quick brown fox jumps over the lazy dog, period. Make sure that you don't use any characters that are not in your new alpha, okay? All right, so we'll run that. We'll say enter mode. We're going to do encrypt. So first we're going to encrypt it, and there's our encrypted string, right? We don't know what key was used to encrypt this message. We have no idea because it was random, right? So I'm going to press Y, and that's going to crack the encryption, and we're going to watch what happens here. So as you can see, we get a huge amount of output. And if we scroll up, eventually we're going to see some plain English. And sure enough, a key of 27 was used to to encrypt this message. Let's run it one more time. And this time we will say, I love pie, particularly blueberry pie. Oh, that's illegal. So we'll run this one, and then we'll say encrypt. Again, it's going to be a random key. Uh-oh. Oh, the comma. Whoops. Okay, run it again. I love blueberry pie. And I really do. Encrypt. There's our... Uh-oh. I think our key... our key did not do a very good job. Sure, let's crack the encryption. I've never seen that happen before. Wow. Okay, where is it? Let's see here. It's probably... Is it at the very end? No. There it is. Key of 26. Ha! That's because it's like the exact length of the lowercase alphabet, I guess. All right, but basically you can see how this works. You guys can tinker with it as much as you want. There's ways to make this a little bit more complicated, but you don't have to. All right, we're already running up on 8 minutes for this video. I promised you a short one. So all you've got to do is include these parts of the code in your final project submission. Make sure you get this guy in there along with these changes. Okay, and you will be good to go. I look forward to seeing you guys soon, and I hope you have a good weekend.